Hello, welcome to my channel, Network Simple, and today we're going to learn what is an STP and what are the RSTP, which is the newer version of the STP protocols. Now in the STP, we need to know first what is a BPDU, which is a Bridge Protocol Data Unit. Now this Bridge Protocol Data Unit, before we move on to the rest of the contents, I want to keep in mind is that it just means the port state, which is root designated port, which is root port and designated port. These are the exchanges that goes between the STP. So BPDU means just that. And the STP operates by selecting a master switch and a running tree-based algorithm. So it identifies, okay, this is the master, okay, and then we have the slave switch, like its branch. And it will just go down, it will start streaming down to stop the loop. And that is the whole concept of STP. Since switches, by the way, they broadcast messages, okay, to everyone. So we need to control that broadcasting part. That is why we have this structure. Now we have different type of STP. This is the oldest version, and then they created for the per VLAN for the per VLAN, but it is still an old version of STP. Then we have the PVST, which is the newer version, and that and it works with the STP Cisco. So the old version of the Cisco, since they are already running 802.1D, to upgrade to the per VLAN, this is the function. Then we have the rapid spanning tree protocol and multiple spanning tree protocol, which is VLAN and then multiple VLANs. These are the nodes. These are the nodes I collected. This is the old version of the STP. It has the slower convergence rate. So even when there is a link failure, it will take time, a minute or two. So that's the whole idea. Okay, so PVST means each VLAN gets its own STP. Okay, switch one. Then we have the per VLAN. It is the Cisco improvised version of the PVST. Then we have the rapid spanning tree protocol. The difference is the waiting seconds. So it goes from blocking, listening, forwarding to discarding, learning, and forwarding. Directly, it will learn and forward. And then we have the MSTP, multiple spanning tree protocol, which is multiple VLAN is able to go fast, rapidly go into this mode, learning and forwarding. So these are the version for the STPs. Then we have the port state, which is what is the port goes through disabled, blocking, listening. The main one these are the main one: listening, learning, and forwarding. Okay, it learns and it listens. If it's learning its environment, scanning, then it's learning, am I a designated port or a root port? And then we have the forwarding. It will start exchanging the BPDU, okay, MAC address, like the traffic can go now. And then we have the broken. So just it's literally by the name itself. So there's not much confusion. It's literally take it as the name, okay. Now we have the root port, receiver, designated port, sender, and then the blocking loss. So I want you to focus on this receiver and sender, okay. Then we have the root bridge, which is the main switch, okay. Then we have the BPDU, what I said about designated port and root port, configuration of, okay, now which one should I change or not. Then we have TCN, that will be the total cost of to reach point 1 to point 2. So basically, how my PC takes how my PC takes to go to the default gateway, which is the main switch, and to send it to the router. So that's point A to point B. So TCN. So any changes within the structure, okay. Now one of the switch that I'm passing through, it's broke down. So is there a new backup port or not? So that will the changes to forward the traffic. That will be called TCN BPDU. And root path cost, that's it. For the TCN. I was actually telling you about the root path cost, which is from point A to point B, network default gateway. And then we have the main part, system priority, okay. Local bridge is now every switch thinks that I'm the main switch, but as it receives its BPDU, which is the root port designated port part, it then learns that hey, there is a master switch. So master switch, they will have a master switch identifier, and then will have their own local means their own ID, and root bridge it means their master ID. So max age is the MAC address retaining in the switch. So, okay, it means also that any changes in the BPDU or not, then the hello time, the switch will constantly say to this other switch, hey, are you alive? Are you alive or no? Then we have the forward delay. That's the amount of time that stays in listening and learning state. It means that after getting the hello and hi, it also keeps learning that okay, there's no changes in the port, there's no changes in the structure. So max age is the like when it stops receiving anything, it will have 20 minutes before it changes to, flashing before learning, resetting up. So these are the example, by the way. I wrote it down. You can take a switch. It means you can just take a quick learning about this. Okay, you can pause it out. And what is it? I took it out from the chat GPT. It had a really good understanding what I was trying to understand. It replied to me in what I wanted to understand. Okay, by the way, the system priority always have a 3 to 7 edge, so the lower is more better. And this is how it gets calculated. Okay, if you have it VLAN 10, it gets added to the system priority. So you have, when it's a root bridge identifier, it will look into this. It will add more with the root bridge, and then they have their own local bridge. So this is what I was saying. 20 seconds it's all, and recalculates STP since BPDU. If we see I'm the root, and then it says, hey, it waits. Is there any changes or no? So how to differentiate between root bridge and local bridge? See, it will show up like this: root ID, bridge ID. If there's someone else, okay, bridge ID. This is the local ID, and this is how it will show up. And then we have the STP path cost, which is the bandwidth will determine the STP. Hey, I'm more better in choosing for this from point A to point B, and it will change, and it will cat 5, cat 6. This is where the change the path costing part it comes in. Then we have this is the main switch. Okay, root bridge is called the main switch. Now root port is the one that's will let you go to the root bridge. Okay, so root port, even me, I got confused with the root port. Is that when it went to the, like, what is it, root port and what root bridge? What is the confusion? Now the root port is someone who will receive from the root bridge, which is the main switch. And then again, this will happen. Now this is like the tree. Do you see it? This is like the root. So one switch can have one root port, by the way. So it cannot have two designated port. Okay, it can have two designated, but it cannot have one root port. So designated port is the sender. After I receive, it sends, so this is how the structure goes in. Now this is the notes I have. Switch with the lowest. It will look at the switch with the lowest STP identity. It will look into the MAC address. The lower the MAC address, the highest chance of being the main switch, and the priority first. Okay, now the root bridge, that's how it's selected. Then we have the root STP cost selection. Now this one is the best for the towards it configuration. It's just an understand that okay, this is how it's calculated. The first hop isn't calculated. The second hop has the path cost by 4. And yeah, that will be the how its path costs are calculated. The advertised root path cost is always the value calculated on the local switch. And then we have the root ports. Okay, it looks at the system priority, system MAC address. You have the port priority number. Is it you given a port priority or port number? So this is what it looks like. See, if it's tight, you can pause it up. What does it look like? Okay, so main thing is the system MAC, system priority, system MAC address, and system priority. So this is now to understand this diagram. I was able to get this answer. So both switches in this diagram, it shows especially the root port. It calls the root port. This is the root port. Okay, and the root cost. That's it. Switch 2 and switch 3. reach the root bridge to G10, G01. It's all the same. Root ID. So in here it shows the first, okay, the root cost is that it shows that, okay, this switch is next to the, this is the this is what the root cost is, okay. So the local root path cost is the advertised root cost plus the local interface cost. So that means it will take this and then it will add its own root path also. So that's why it's root costing it, and you will see that it will add from 4 plus 4, and you will be able to understand that the Ethernet cable, these are the Ethernet cable by the way. And yeah, now you will have the root ports, okay, we talked about it. Then we have the root block designated port, switch ports. Now what is it is that locating the switch with the better path cost for the vehicle preferred site stops the loop. Okay, you can look at this. Okay, after root ports are selected, root designated port, block port stop to prevent decision order to prevent two non-resist, lower path cost plus the higher path cost. So if it's take more high path to reach to another path, it will stop that. And if cost ties, the lower switch priority wins. If the priority ties, lower switch MAC wins. Okay, so it always comes to the MAC address and the system priority. Then you have the viewing the STP information. P2P. By the way, do you understand what is a P2P? P2P is for the switch to switch, and P2P edge, it means from switch to the devices. Designated forward. Listening. This is what it means by edge, port fast, forwarding immediately. This is the for the local STP bridge. The cost, the port, verifying the route and blocking ports for the, it doesn't, hello time. There is the ID, route, designated port. So it will show you the root port, and then it will show you the designated. And if it's and it's not written yet, but you should be able to see alternate port in the role, which means block. So same in here, you will be able to see it's the same show spanning tree. Either you can choose the VLAN or you can choose the interface to see the same information. Okay. Then you have the TCN, BPDU change flag set, then and it is flooded if in a stream. Now in this scenario, we have there are changes in the topology. It changes any change in the switch status. Okay, the link status. It sends us acknowledge forwards the TCN to root port upon receipt of the. See now when it's when there is a failure in the link, okay, the default timer is 15 seconds. Then it removes the MAC addresses from that device to, and then there's a change. Now when a switch receives this, let me see video, and then if one switch receives this, they set their MAC address. All the switches will, this will be just not the root bridge, it will say, okay, there's a change in the topology, all the switch, now they will re-enter which is the correct path. Show spanning tree VLAN detail to see the topology changes. Okay, detail, and each the more you will see that it's changing way too much, there's an issue. It should have a long status like days and all. Now converging from within the direct VLAN. Okay, now this is the structure. Okay, when a switch loses power or cable, I wrote the same thing from here. Okay, it recalculates if the switch 2 and switch 3 fails. Switch 2 and switch 3 fails, it will send to the switch 2 will send to the switch 3. If they both will send the TCN from their root port. Hey, I have a link broken, and then it will see what are the traffics affected. Anyway, it won't change. It won't change anything. Okay, I asked this question. It was already blocked. So switch has something changed in the layer 2. This will be the before the block. Since it was already there, it will just recalculate it. It relearns mega from the. See, this is the answer. Even though it's not affected, it still relearns. This is the notes I found up. So usually the STP, you can stop. It goes from by the, usually stops. Okay, any changes? It learned before failure. This is the answer. Before switch 1 learn PCA behind PCB. After link and TCN change message, macro forget or relearn. Link goes down, switch to. If this link was blown, not right, because it's switch 2 and 0. And if switch link fails, switch 1 to switch 3 goes down. Because now the whole concept, of course, now the whole concept of this is that if the link fails over here, okay, for the switch 3, the root port this will be changed to the switch root port. It will start the root bridge will learn, hey, I cannot send the TCN, okay, the bridge, both of them will try to send the message, but it won't be able to. It will detect the issue. So what it will do, this switch 3 also will start and it will become the root bridge. Okay, now since it doesn't know it's root bridge, it will go into the root bridge mode. Okay, now when it's turned into a root bridge mode, it will send to the switch 2. The switch 2 will now calculate, hey, I'm receiving 2 information, but it will also see that he has the highest priority, lowest priority, and lower MAC address. So it will say, okay, there's a change, and switch 1 is also notifying me. It will take its command and then go here and say, hey, there's a change. There is a change with your switch. Please acknowledge it. And then the switch 3 will say, yes, there is a change. Now it will change into the root port. So the blocking port will now change to the root port. So that's the whole concept. If the blocked link fails, no traffic. If an active stop until STP unblocks a path, TCN tells switches to clear all MAC paths, and VLAN. See, this is that's the idea. So phase 1, this is the same thing. Okay, this is what I wrote. These are the notes I wrote. You can take a screenshot or I will just explain it. Well, this part was very confusing for me also, what they written on it. Phase 1, switch 1 detects a link failure on its G103, which is this one. Switch 3 detects a link failure on its G101. They both detect it. Phase 2, normally switch 1 would generate, this switch 1 will generate a TCN flag out its root port, but it doesn't have its switch port. So it does not, switch 1 would advertise as TCN if it were not the root bridge. Switch 3 remove its BPDU received from the switch 1. Now switch 3 will remove any receiving information from the switch, okay, from the switch, because it's now down at this switch 3 would, now it will say, hey, now it will become the main part, and it will however its root port is down. Okay, so in switch 2, phase 2, they're still learning. Now the master slave conversation is happening. By the way, you can take a screenshot. It goes you can post it down. Okay, this is how I wrote it down. Is it goes like this. Okay, these are the phases I wrote. Switch 2 does not say because switch 1 is already in the. Then these are the phases. Switch 3, then TC flag. This is not the same as the TCN, but with the meaning topology start aging, clearing MAC address. Switch 3 wants to send TCN but cannot. So switch 3 should send towards its root port, but its root port was blocked. The root, now the G01, so switch 3 way, and then uses the backup port. Now the backup switch 3 ports to switch 1 was blocking. So it waits to from listening, learning, and forwarding. Then switch 2 can reach the root through switch 2. Switch 1 does not TCN, but these are the all phases. This is the all phase, and this is a shorter version of the phases. Okay. Now, yeah, so this is what this switches and reduces. Now this is what it means by the direct link failure, and relate to the switch 1 advertises a configuration BPDU change flag set. Out of all its port, the BPDU is received and relate to all switches. Okay, switch 1 will now say, hey, there's a change in the network. Now we can now it will broadcast that message. Then switch 2 and receive that configuration with the topology flag set. Then everyone changes the MAC address each time and forward to flush out all MAC address. Switch 2 does not know what changed in the topology, so switch 3 must wait until it hears from the MAC is failed. It then reset. So MAC's edge timer is a very important thing before it can reset, which was the blocking state G102. This one, okay. And then we have the another part where it does the where it does say, okay, where it will now in the switch 2, okay, now the root port, okay, both of now this part was the designated port, right? Now this will now G103, now this one G103 will now change to the root port, and this will change to the designated port, and that's it. The root port and designated, it will change to it will change from block to the designated root port. It will change to the designated. That's it. Before it was, so it's switching the role now. So what happened is that this is the conversation of the 3 phases linked between switch 1 and switch 2 fails. Switch 1 is the root bridge. It cannot send sense the root port. It sends out TCN from the root port. It cannot. So switch 1 sends from the switch 1 sends it. The switch 1 sends it. Switch 3 receives the switch 1's BPDU and clear all MAC address. Switch 3 also receives switch 2 BPDU but ignores it because switch 1's BPDU is better. Switch 3's block port G1 waits for the A, then it starts moving from blocking to listening. Switch 2 receives switch 1's better BPDU through switch 3. It will now receive switch 1, changes to switch 1, and then switch. This is the switch 2 receiving it. So this is the phases. This was the diagram part. Now in the phases of phase, okay, G101 and switch 1, G103. So since both of them were done, okay, so G101 and G103 were both done. Switch 1 is the root bridge, so it does not send. Switch 2 loses as well, so it cannot then send a TCN forward. Switch 1 sends BPDU with topology sends change. Switch 2 does not hear those, so it temporarily advertises. So same part, I'm rewriting, by the way, all these 6 phases. I'm rewriting it, like what's happening and all. Switch 5, then in the 4, it hears from the real root. Switch 3, trust switch 1, I ignore switch 2 weaker. Now switch 3 also clears the MAC address from blocking, listening, and learning and forwarding. It then changes to this. So switch 2 receives the better BPDU through switch 1. Then from the block state, it will change to the G103. It will change to the as its new root port. Final path becomes switch 2, switch 3, switch 1. By the way, this part was so hard for me to understand because the diagrams were giving lots of information. But somehow, this was the answer. Switch direct had the backup port, but it was blocked. STP waits and open the... So this is the final idea. Converging, okay, root bridge. Switch to assume that it is now the root bridge, and the vertices BPDU with itself as the root bridge. So any switch that goes down, it will start thinking as they are the boss. Switch 3 receives this information, but change topology from the switch 1. Switch 3 reduces the MAC address age to forward delay. Don't worry, guys. If you're forgetting what is a forward delay timer, I will write it down in my description. Okay, so it will be easier for you to go back to each time. Expires, so it needs to re-expire. So there's two stages. Okay, first it needs to expire its old version. Okay, it will receive an information that I need to clear everything what I had. Okay, once I clear out what I had, it will then relearn. It will then relearn the again everything, the max age timer expire, and now from blocking to now it will relearn everything. So yeah, only one time it will flash out, and second time it will start learning again. So that is it of the direct link failure. Then we have the indirect link failure, which is the idea is that meaning the cable between switch 1 and switch 2 is physical, but the data are corrupted, not reaching. Data and the link still, but the BPDU are not working. So switch 3 receive from switch 1. Switch 3 wait for the max age timer before changing anything. Switch 2 still receive good PV from switch 1. Switch 2 is still receiving from the main switch. And then forwards to the switch 3. After maker starts using G102, then this will just change to the root port. So because to receive or send anything, root port is important. It moves to listening and forwarding. Yes, in the diagram, G102 was already blocked from the failure before the G10 root port. So same scenario. Indirect anyone occurs, switch to needs to remove the max age timer from the root port, transitioning from blocking to listening state. By the way, it doesn't need to have this many phases. It just need to say, hey, I'm getting blocked. I need to, there's only actually 3 steps in my own words. Okay, all of it is just that if the link is detected, second, it will try to be, it will stop receiving any information from the main switch. It will, in third phase, it will just clear out everything. Within the second part, it will clear out everything. And then the third, it will become the main switch. But in the fourth part, it will say, hey, why aren't you listening to me to the other switch? Then we'll say to the one with that broken link, it will say, but you know, we have already the main switch. Now this is the command. Listen and do it now. That's it. And so switch, so yeah, pause it out and see through it. Now we are done with the fundamentals. Now we can start with the RSTP. So the RSTP is the port state to be faster, and so it just needs how fast can you go to the forwarding state. So discarding learning and forwarding, this will be the port state, okay, for the RSTP. And the same thing, alternate port and backup port that provides alternate port is the blocking port. The backup port is where I made the port that is blocked, or I made it as not usable, and it will it's working as anything you're doing intentionally. That hey, if my port goes down, this will be the second backup port. So this will fit more into the switch 2 scenario. So that will be the backup port. Exists only when multiple connects between the same switches. So if it's connected to the same switches, you can create the backup port. Alternate connectivity to the root switch to a different switch. So alternate port will be this, okay? This will be the alternate port. But if it has too many connections, you will say, hey, if my main link fails, there is another link that I have, you can use it. So there is no need to change any path. So everything mostly will be the same. Root port, edge port connects to the layer 2, okay? Edge port and root port. Host, which is the devices connecting to the switch. Root port has up towards the root port, point-to-point port, which is switch to switch. Building an RSTP topology, you need to have, there is a part called full duplex. Okay, so same scenario, no changes. Okay, this is the whole. I wrote it down all the part. Okay, they establish a handshake with each other to avoid us, which is root port and designated port. They can be only one designated port per second, so each switch, whether it's superior or inferior, until the system identifier with the lowest MAC address. Same thing, and then recognize it's inferior, and it will say, okay, should I send it to the blocking state or no? So between the two parts, it will when it settles down, it will say, hey, now we agreed to this. Now the next one, okay, the switch 2 and the switch 3 will talk like this. Then the switch 3 with the switch 4 will talk like this. Switch 1 is closer and better, so switch 2 makes the root port. So same thing will go with the switch 3. You can forward, both parts go forwarding, not long listening wait like. So the whole idea is RSTP to move along with the another part. So this is the idea. Can I forward on this link? Yes, I synced it. You can forward. Better root side downstream. Okay. There we go. We finished our STP fundamentals where we learned how the switch forwards the traffic, when do they block, and how the designated ports are switched, determined. So if you like this video, and if you had any information that may not be correct, or you didn't get the idea, you can just write it down in the comments. And of course, anyone, please help each other out, and I will try to reply to the comments. Thank you.